The lab work for the introduction to LabVIEW that we have for the Dynamic Systems and Controls lab is often run as an independent lab. So when you go into the lab work summary, you'll see there's a stated goal. The goal is for you to start taking the first steps into learning how to use LabVIEW on your own. And again, sometimes this is a lab that's run in lab with the TAs, depending on the schedule, but oftentimes this can be done individually on your own. And we expect that you will figure out how to download LabVIEW, which is available as a site license for you students at the University of Texas at Austin. And I'm taking the opportunity to show you that for each lab work that will be posted throughout the semester, you'll see that there are a summary of guided exercises and independent student exercises. So in other labs, you'll see under guided exercises will be a list of exercises that the TA will run through with you to show you how to do certain things, and then there'll be a set of independent exercises that you are tasked to do on your own. In this case, these are all independent. So there's only 3 items that you have to do. You go and install LabVIEW on your computer. If you choose not to do that, you'll have to figure out how to use the remote access for LabVIEW so that you can complete this experiment and any other future experiments. And then there's 2 major tasks as lab work, if you like. You want to go and read the Getting Started manual and tutorial that's available from LabVIEW. I'm referring to a 2013 version. There might be updated versions that you could find online at the NI website. We're going to go through chapter 1 and 2 for this lab, and you'll see that chapter 1 is getting started with LabVIEW virtual instruments, and it walks you through building a virtual instrument, launching LabVIEW. So these are all things that are meant to be done on your own. And there's a nice tutorial here. There's a little exercise that they walk you through, and then at the end you build a simple VI, your first VI if you've never used LabVIEW. If you have used LabVIEW, then this is going to be a relatively simple exercise for you. Going back. So you should gain sufficient understanding in this first exercise that you can generate the table that's listed on page 117. And the second one is to complete the exercises so that you can configure VI to run continuously. Again, these are meant to get you up to speed. Let me jump to the lab evaluation. By the way, it depends, but if there's no pre-lab, that usually means that there is no lab meeting. Since there's no lab meeting in this fall semester, there's no pre-lab required. Okay. However, there is an LE, and you're going to see that the LE for this first lab requires you to build your own VI, where having learned how to build a VI using the Getting Started manual on your own, or again maybe working with a friend, you then will go and build your own VI that demonstrates how to enter some XY data and then how to plot that XY data. Okay, and then you also are going to learn on your own how to add a linear fit between that X and Y data. And both of these note have submits on them, so you're going to submit these 2 things. And then we're going to ask you to use a proper format for your LabVIEW, for this LE. Okay, I'm going to go through a few slides that just summarizes just what I just said. But as you can see, it's a relatively straightforward first lab that you will do independently. So when you go into the Getting Started manual, it'll summarize for you. It gives you an introduction to what LabVIEW programs are. They're virtual instruments. These are things that we expect you to know when you come next time to lab. You'll learn how LabVIEW VIs have a user interface, a front panel, and also a block diagram where you actually do all the programming using graphical programming. And LabVIEW software programs are used to communicate with hardware instruments, and you're going to see in future labs that LabVIEW also has environments where you can build you can build simulations of mathematical models, and we'll talk more about that in a future lab. So here's the basic idea of a LabVIEW program. If you've never seen it before, there's a front panel that has ways for you to communicate with the program, say through some knobs, inputting data in different ways, and then there's output in different ways. Again, it could be a graph or it could be a display. There's also buttons where you can run and stop the program and so on. A lot of different ways to build user interfaces very quickly. And then there's a block diagram on a different window that allows you to do all the graphical programming. This shows how the knob shows up on the program as an input device, and how the graph shows up as an output device, and how you use these different types of signals to communicate information between these different elements. So these blocks here represent specific available programs within menus available in LabVIEW. And these are called express VIs. They have kind of high-level functions. So in this case, one of the examples in the Getting Started manual shows you how to generate a signal of some type. You can tell it, I want to generate a sawtooth signal, and then you run it through a formula VI, and it merges those signals and plots them together. So you'll work through these examples in that tutorial. And again, part of that is for you to become familiar with this environment, so that when you first come to lab, either next week or the following week, you're ready to get started with the next laboratory. So here's the introduction to LabVIEW. Again, it's meant to have you do this on your own. You're going to be using LabVIEW throughout the semester, and it should not come to a surprise that in your final hands-on lab quiz, you're going to be asked to use LabVIEW. You need to practice using this independently as well as together with your lab mates. There's a lot of tutorials that you can find online, you know, from National Instruments as well as from other people. So, you know, make use of all that. And finally, another thing that we want you to do in this first lab is to start, you know, developing a good reporting style, which is reporting all your work through these lab evaluations. Summarizing, there's no pre-lab for this particular lab if it's during the fall. Sometimes in the spring semester, if we are meeting in the first week of labs, you might have a pre-lab that's asked of you. But in the lab work, you'll be given a set of exercises. I've already reviewed that in this video. But remember, you have guided exercises as well as student exercises. That's the general format for all lab work in this course. And finally, you'll be asked to do a lab evaluation. And again, this lab evaluations consist of specific questions. And each weekly LE is due at a time that's going to be specified by your TA. So if you're not clear when your LE is due for this first lab, make sure you contact your TA. We expect LEs to be prepared professionally and neatly. And remember, you can work cooperatively with someone, but all work should be your own. You should have your own input to each of your LEs. It should not be a duplicate of your lab partners. And especially for the first LE, this should really be independent work. Here's the specific LE that you'll find posted. There's two tasks that you're asked to do on this first LE. One is to basically build a VI where you can input data and plot it. And the second part of that, and then you're supposed to submit the actual VI to your TA as a screenshot, not as a VI program. You're supposed to take screenshots, put it into a document, and that's part of the PDF that you upload as part of your LE. So you are not going to be allowed to upload a VI program, only the screenshot. And then you're going to do a linear fit also on the data, and that's your second step. So this will also show you what percentage each is worth. Finally, in the lab evaluation format, I want you to put your name on each page. Again, even though these are uploaded into Canvas, I would like for you to have in the center here that this is the ME144L lab, the lab evaluation number 1. The name of your TA is, for example, Bakshi is one of the TAs this semester, and the date. And each LE should have a summary at the beginning. This is just, you know, what was this lab about? What did you do? 3 or 4 or 5 sentences, nothing long. You know, it could be like an abstract, and that what was done, what was found out, and should not be very long. And then start including each of your questions. Okay, so very simple format for you to follow. Okay, your LE does not have to be typewritten, but it does have to be neatly written and legible. And just so you know what's coming up, again, this is the introductory lab. The following lab is going to be building on your knowledge of LabVIEW to begin building and running LabVIEW programs that control data acquisition. So you need to make sure that you prepare yourself for that and come in knowing how to use LabVIEW. You're going to start experimenting already with the simple pendulum. And then in the following week, we're going to show you how to use the LabVIEW environment to build simulations of mathematical models for that compound pendulum, which is the first physical experiment. So as you can see, these first 3 weeks is meant to have you build up your LabVIEW proficiency. So take the opportunity in this first week to get started.